amazing class. As you know, I am in Joshua Tree National Park and we have our amazing, fabulous sub, I don't know which way to point, taking over our class for the next 2 days, but at least you guys get to see my wonderful face for math. All right, so today we're going to be learning about the volume of cylinders. This is going to kick off our volume unit. Be sure to grab your paper, pencils, get ready for a warm-up word cloud. I'll see you guys on the next slide. All right, I just got to make the joke I always make when I make these. We're recording, and this recording is inside of a recording. So as stated on the first slide, today we're going to be learning about the volume of cylinders. There's going to be a formula you want to write down and memorize for this one, guys. And now that I've slightly improved the glaring light on my face, you guys go ahead, pause this video, do this warm up. I want to know what is a radius versus what is a diameter? What is the relationship between the two? Just pop something brief into the word cloud. All right, guys, if you struggled with that warm-up, no worries, because we are going to look at this stuff right now, radius versus diameter. Now, this should be review for you guys, but if you didn't know, be sure to write this down in your notes, okay? When we're talking about the radius, this one right here, we're talking about the distance from the center point of a circle all the way to the edge, okay? So what that actually means is that this circle here has bunch of radiuses. So if we just made a bunch of lines like the spokes on a bicycle tire, those would all be the radius. All right, let me get rid of that so it's not busy on the slide. And then if we look over here at diameter, this guy here, diameter, what we're talking about is going all the way across, So if you could think of the diameter as if we squished the earth flat and then looked at the equator, or it's like the band that goes around the circle's belly. So the diameter goes all the way across, and the radius starts at the center point and goes out to the edge. The difference between these two is important to note because we use different values when we're calculating different things dealing with circles. So again, the diameter is the full distance across the circle, swoop. The radius is half the distance across the circle, swoop. So what you need to know is that if a problem gives you the diameter in the description, then you need to divide it by 2 to get your radius. Why would that be? Well, because if I started with my radius here, here's my radius, let me highlight that. There we go, there's a radius. And if I extended it to the other end or doubled it, I would have the diameter. So what does all this mean when we're talking about finding the volume of a cylinder? All right, so this is the formula I was talking about that you need to write down and you need to memorize. There's going to be quite a few of them in this unit, but don't worry, I'm going to provide you guys with a cheat sheet as well. So when we're looking at this formula for the volume of a cylinder, formulas, we always write those with capital letters, okay? We've talked about this in science before, not too much in math, but capital letter indicates a formula. So if we come over here and we look, we have capital V standing for volume. What we have next is we have this crazy number here, pi. We're going to talk about him in a minute, but if you don't remember who he is from last Friday, hello, Pi Day. This is approximated as 3.14, but this is an irrational number that goes on forever. We multiply the pi by the radius squared of the circle, and then we multiply that whole thing by the height of the cylinder. Okay, so what does that mean? The volume of the cylinder, or how much we could fill this cylinder up, is equal to pi times the radius squared times the height of the cylinder. If you look here, here's a little legend on what these other letters stand for. R stands for the radius, and this is always true in math. Anytime you see R in a formula, it's going to stand for the radius. Just as most of you already knew that H stands for height, H is the height of your cylinder. There's a couple important things to note here. Okay, there's the exact volume versus the approximate volume. What we want to look at here is exact versus approximate. These are when we're dealing with pi, okay, you guys? These are when we're dealing with pi. So let's talk about the exact volume first. When you're asked to find the exact volume of pi, pi stays, well, let me rephrase that. When you're asked to find the exact volume of a figure, pi will stay pi in your answer. You do not substitute it for 3.14. All right, and we'll look at some examples of this. And if it says approximate volume, it wants you to approximate pi. And what do we approximate pi with? 3.14, that number that you are probably already familiar with. So when you're asked to find the approximate volume, pi will be replaced with 3.14 in the formula, in the equation. All right, let's look at some examples of this. All right, here is our first example. So we have a cylinder here. Okay, the cylinder has a radius of 5 centimeters and it has a height of 6 centimeters. That's all the information we need to find the volume, or if we filled this all up with sand or water or whatever you want to imagine it as, if we filled this all up, how much would be in there? All right, so here's our simple steps. Substitute R and H. What do we substitute? Our radius and our height. And then we simplify. But we find the exact volume. See, find the exact volume. That means pi will stay pi. We're not going to touch pi as we simplify and solve this equation. All right, so let me grab my pen and let's dive right into this. So our first step is to substitute R and H in our formula. All right, so let's go ahead and do that. All right, so let me write my step 1. I'm going to rewrite my formula with R and H substituted. So that'll give me volume equals pi. I'm going to rewrite the formula first. R squared H. And then that will give me, when I replace the radius and the height, I will have volume equals pi times 5 for our radius squared times 6 for our height. And now let's go ahead and simplify this. All right, now remember, pi stays pi. We're not going to replace that with 3.14. We're going to leave it just as the symbol of pi. All right, so our next step will look like this. Volume. Why isn't my pen working? What is going on with my pen? Why we no worky? Come on, pen. Oh, there we go. Volume equals pi, and then 5 squared. If you don't know it, plug it into your calculator, but this is one that you should have memorized. That is going to give us 25, and then we're going to multiply that by 6. All right, one last piece. We need to combine our like terms, our 25 and our 6. We have to multiply those together. So that will give us volume equals pi times 150. Now, if you didn't know 25 times 6, go ahead and plug it into your calculator. All right, but wait, there's more. We're not quite done yet. This is the correct answer, but it's not in the correct format. Okay, we need to simplify this. All right, so let's come over here and let's write this in the correct form. We have our volume equals. First, we're going to write our 150, and then we're going to write our pi. So when we find the exact volume, we kind of treat pi like a variable. We just attach it to the end of our number just like this. And then we cannot forget our units. Units. Units are so important in geometry when we're talking about actual lengths and widths and heights and volumes, areas, all that junk. So our units here is going to be centimeters, but then we need to attach an exponent. And when we're dealing with volume, we are in centimeters cubed. Okay, cubic centimeters, or centimeters cubed. So this is a must. When dealing with volume. Now in this next example here, you'll notice that our instructions are slightly different. Find the approximate volume. So when it says approximate volume, that's when we want to go, all right, I know what to do. I am going to replace pi with 3.14. Sorry about my sloppy approximate equal symbol there. So we need to replace pi with 3.14. And our instructions tell us that as well. So step 1, we're going to substitute R and H. Step 2, we're going to simplify. Start with your exponent. Always follow PEMDAS. PEMDAS doesn't go away. And then finally, we will substitute 3.14 and round if needed. What are we going to round to? We're going to round to the second decimal place or the nearest hundredth. All right, so let's get into this and let's read this problem. All right, so we don't need an image to solve these. We just need the information, okay? Now, if you want to draw an image to make this more real, then go for it, okay? We will be doing that in the early days of practicing with the volume problems. But here, we have all the information we need. So we have a cylinder has a diameter of 8 inches and a height of 10 inches. So let's go ahead and let's underline that important information. 8 inches, which is the diameter. Careful, careful, careful. It's not a radius, it's a diameter, so we're going to have an extra step to take here. And then a height of 10 inches. So first, let's draw ourselves a picture so we can visualize what the cylinder would even look like. All right, so just sloppy cylinder. It so does not need to be perfect. Look at how sloppy mine is. La la la. It kind of looks like a can that a kindergartner drew, but that's fine. Okay, and then we're going to go in and we're going to plug in this information that we found in our little word problem up here. We have a diameter of 8 inches, which means that all the way across, diameter equals 8 inches. And we have a height. So let's go ahead and make our little height marker. And our height is 10 inches. So step 1, actually, we cannot substitute R yet because we need to find R. What is the radius? Well, radius is half of the diameter. So our radius equals 8 divided by 2 because it's half of 8, which means that our radius equals 4 inches. This is the number we are going to substitute in our formula. All right, so step 1, substitute R and H. So we're going to let R equal 4 and we're going to let H equal 10. Start off with rewriting your formula every time. It helps you memorize it. R squared times H. And then I'm going to replace my R and my H. So I will have volume equals pi times 4 squared. That was a little sloppy. Let me fix that. Goodbye. Squared goes on the outside. And then we're going to multiply that by H, which is 10 inches. All right, so let's simplify this. First, we start with our exponent. 4 times 4, or 4 squared, is 16. And bring down all that junk that we have not used yet. Don't lose your pi. All right, now the next step we need to do is combine our like terms, which is our 16 and our 10. So we'll end up with volume equals pi times 160. Whoops, sorry for that slop fest. All right, but wait, there's more. We need to now follow step 3. Here, let me write this in here. This was step 2. Here is step 3. We need to substitute 3.14 for pi, and round if needed. All right, so my next step is going to look like this. Volume equals 3.14 times 160. Now, you guys know I'm good at math, but I'm not that good at math. I'm actually going to bust out my calculator too for this next one. So please feel free to use calculators in this unit. You guys know they're allowed in class. All right, so I'm going to have 3.14 times 160. Sorry, I'm working off camera. And I end up with volume equals 502.5 3.4. Now I don't have to round because I'm already rounded to the tenths place, so we're good here. Leave it like this. Just get those units in there. Units. What are our units? Let's find out. Inches, inches, and since we are dealing with volume, this is 3 dimensions, or the third dimension that we're in, so it's to the third power. And that is our approximate volume answer. Now, on the flip side, our exact answer would have been 160 pi inches cubed. All right, here we go. In this next problem, it's actually going to ask us to find both the exact and approximate volumes of this cylinder. Now, do we have a picture of a cylinder? No, we do not. So we want to draw another kindergarten cylinder here, just so we can visualize what's going on here. So let me grab my pen real quick. And let's read with my laser pointer. So find the volume of the cylinder. Volume equals pi r squared h. All right, we have everything we need. Let's go. So first, let's look at the information that we are given. R equals 8. Yay! We do not have to divide it by 2 because we're not given a radius here. We have we're not given a diameter here. We already have the radius. And we have a height of 2 centimeters. So let's draw this sloppy can. All right, can I connect a line? I guess I cannot today. There we go. There's our sloppy cylinder. I want to get that. Well, there we go. There. I'm not going to obsess on it. It looks fine. All right, and let me switch colors real quick, and we're going to show our radius. So the radius starts in the center and goes to the end. Our radius is 8 centimeters for this problem. And then let's get our height in there. So I'm going to put a little height marker. And our height equals 2 centimeters. All right, now we have everything we need to get started on this problem. So let's think. We don't have the steps in front of us this time, but fear not, it's still the same steps as the last 2 problems we did. We need to replace the radius and the height in our volume formula and then simplify. All right, so step 1, let's rewrite the volume formula. You should rewrite it every time until you have it memorized. I have volume equals pi times radius squared times height. All right, I'm going to let r equal 8, and I'm going to let h equal 2 in this equation. Volume equals pi times 8 squared. Oh, I did it again. I'm just going to leave it this time. Times 2. All right, so the first one we want to deal with is the exponent because PEMDAS always reigns true, and we handle our exponents first. So 8 times 8, or 8 squared, is 64. Check it in your calculator if you don't have that one memorized. And then I got to bring down all my junk that I have not used yet. Don't lose your pi. All right, so now we're going to go first for the exact answer. The exact answer first. So here's our exact answer. So to find the exact answer, all I need to do is multiply my 64 times my 2, which is going to give me 128. And then this is what the equation is going to look like right now. V equals pi 128. So technically we're done, but we have not formatted this correctly. Because when we leave pi in the equation, he needs to go at the end. We treat it like a variable. So I'm going to reorder this to go volume equals 128 pi. Last thing we need is just our units. So if I look up here one more time, I see that I am in centimeters. So this will be centimeters. And we are in the third dimension, so it's cubed. All right, so there is my exact answer. To find the approximate answer, we just need to take one more step. We need to let pi equal 3.14. All right, so I'm going to bring up my exact answer here. Volume equals 128 pi. All right, and then I'm going to replace pi with 3.14, like I said right here, because I'm approximating pi. So volume equals 128 times 3.14. Okay, again, I can't do that one in my head, so I'm going to bust out my calculator, bust out yours as well. So I have 3.14, or 128 times 3.14. And that is going to give me 401.92. Now, again, if I had more than 2 decimal places here, I would need to round, but we're rounding to the nearest hundredth, so this is good to go. Last part is we need our units. And we already found our units to be centimeters cubed, so I'm just going to tack that on the end here. So now we can see our approximate answer, and our exact answer. Now, normally this is the portion of the lesson where I would be asking somebody to come up and help me solve this one, but unfortunately, I'm recording this multiple days before you guys are going to be seeing this lesson, and I am currently relaxing and chilling in Joshua Tree National Park. So let's go ahead and just do this one together. All right, so this one is again finding the exact and approximate volumes of the cylinder. We want to do it both ways, exact and approximate. All right, so let me grab my pen really quick here and let's find all of the information. Oh, actually, in this case, we already have our cylinder drawn for us. We're given an image. So we don't need to go redrawing the image. We just need to pull out what we know from this image. I can see a radius right here, because see how it's only showing half of it from the center to the edge? That's a radius. So our radius is 14 centimeters. And then our height of our cylinder is 22 centimeters. So let me go ahead and notate that. I have my R, or my radius, equals 14 centimeters, and my height equals 22 centimeters. So step 1, I replace my R and my H in my formula. Volume equals pi r squared h with those numbers. All right, so first step, I rewrite the formula. I need to do that until I have it memorized. Volume equals pi times radius squared times height. Perfect. Now I'm going to let R equal 14 and let H equal 22. So volume equals pi, stays pi for now, times radius squared, which is going to be 14 squared, times H, which is 22. All right, now, again, I'm good, but I'm not memorized over 12 good. So I'm gonna plug this into the calculator really quick so I can confirm that I know what 14 squared is. Calculator time. And it is 196. That's what I thought it was. I just was lacking a little bit of confidence there. 196 times, and then we bring down all that other junk, times 22 and times pi that we have not used yet. All right, so now we have volume equals pi times 196 times 22. So again, I'm just going to do some quick math here, combining my like terms, 196 and 22 with multiplication. And that is going to give us a huge number here. We have 4,312, and that needs to be multiplied by a pi. So volume equals pi times 4,312. We're almost at our exact answer. This is just where we need to reorder what's going on here in our answer, okay? Because we treat pi like a variable when we leave pi as pi. So I'm going to start off with my volume equals. I'm going to write my number first, so 4,312. I'm going to tack my pi on the end, just like you would tack on a variable. And then I need my units. Don't forget your units. Our units are centimeters, so this is going to be in centimeters cubed, okay? Because we're in the third dimension, we use cubic centimeters. All right, so there's our exact answer. Now let's get our approximate answer. All right, so for the approximate answer, I'm going to rewrite my exact answer. I'm going to start there. Pi, or a volume equals 4,312 times pi. Now I need to let pi you know what? I shouldn't write it like that yet. Hold on. Let me just get rid of these parentheses. There we go. Now, I need to let pi equal 3.14. So I'm going to replace pi with 3.14 in my equation. So now I have volume equals 4,312 times 3.14. I'm just going to go do a quick little calculation off screen here. 4,312 times 3.14. And that gives us our total volume, which is, or our approximate volume, which is 13,539.68. All right, no rounding necessary because we're in the hundredths place. And then this is going to be centimeters cubed, just like it was in our exact answer. Don't forget to circle your answer. Make your teacher happy. Now there are 2 more slides here, but for the sake of time, we're going to skip doing them right now, and we'll take a look at these when I come back on Wednesday or when we do our mid-chapter review on Friday, okay? But if you guys want to come in and do these 2 practice problems, the solution should be in the notes section, and you're just finding both the exact and approximate volumes. Here's another practice problem you can take a stab at on your own time if you'd like to. Find the exact and approximate volumes. So again, you're going to find the exact and then find the approximate. All right, guys, exit ticket coming up next. But first, let's talk about your to-do. Complete Unit 3, Lesson 2, including all practice problems. This is the most important part, is completing those practice problems, because that is what really solidifies these skills in your brains. So be sure to, at very least, complete your practice problems today, guys. All right, guys, let's look at your exit ticket. Now, I want you to take a moment to try to complete this exit ticket, but instead of having QR codes, I just want you to jot down the answer in your notes for today. And then we'll take a look at this and tomorrow's exit ticket when I return on Wednesday. Now, remember, we need to answer what is being asked. It's asking us for the exact volume, which means, as you can see by the answer choices, we will have pi retained in our answer. Exact, leave pi. Approximate, let pi equal 3.14. So you guys, if we have a cylinder with a radius of 3 inches and a height of 6 inches, what is the exact volume? Go ahead, jot down your answer, A, B, C, or D, and we'll go over this when I return on Wednesday. All right, guys. Have an absolutely fabulous rest of your day with your amazing sub. For ELA, you're in for a treat. You guys are going to start reading Lord of the Flies, and I'm so jealous you're doing it without me. And I will see you guys on Wednesday. But you guys will see me in tomorrow's math video. Alrighty. Have a wonderful day, guys. Bye.